To calculate the entropy of the reaction, we take the entropy of the products, multiply them by the coefficients in front, which is 1 for each of them. There's no coefficients in this reaction. 1 CO2, 1 C, and 1 O2. We'll just be taking the values from the table. We don't need to show that we're multiplying by 1, but we can. For the products, we have carbon, solid carbon, which is 5.6 joules per mole Kelvin. And we have one more product, oxygen, which is given in the table, 205.1 joules per mole Kelvin. So I won't show multiplying by 1 because I'm pretty sure everyone understands that. So this is the sum of the products, and from that we have to subtract the reactants. I won't multiply by 1 CO2. The value is 213 joules per mole Kelvin. I didn't show multiplying by 1, but that 1 would have a unit. It would have a unit of moles.
That's where it counts out moles here.
Right. By multiplying the number n, that's going to cancel the moles in our units, because imaginary ones have units of moles. And finally, when we add and subtract, we will get a negative value, negative 3 joules per Kelvin. This negative shows a decrease in entropy. And what does a negative delta S mean? So we would compare this value with the change in enthalpy. So given this negative delta S, there's two conditions. So we have a negative change in entropy. If our enthalpy was a negative as well, one thing would happen, I'll show in a minute. And if our enthalpy was positive, another thing would happen. So think about what that would be. I should also mention that this is for a given temperature. So when you compare that to this equation, we're looking at these values at a given temperature.
It depends.
Yeah, so let's look at if delta H is negative and delta S is negative, then this double negative would become positive.
Depends which one is greater. If the right side is smaller than left side here, I would say spontaneous because delta G is negative.
Right. So we would say then that at low temperatures, the reaction would be spontaneous. Spontaneous is a negative delta G. So you can see that if the magnitude of T is low, then the magnitude of our negative value would be greater, giving us a negative delta G. Remember, negative delta G is spontaneous, whereas positive delta G is non-spontaneous. Okay, what would happen when the change in entropy is negative and the change in enthalpy is positive? So this would always be positive, and this double negative, this T is always positive, this double negative would also be positive. So delta G is always positive, and remember that's non-spontaneous. So this would be, regardless of the temperature, always non-spontaneous. And that's because we have a positive delta G.